Can you see my screen?
Yes, sir.
So today we'll start up with some of the basics related to geophysical. We are talking about, and we have done a lot of lectures prior to this on what are the various methods for groundwater exploration. Yesterday we studied the weighted overlay method that is used in remote sensing and GIS to identify the area for groundwater exploration. Today we'll be going for the geophysical method for exploration. So prior to that, there are some basic terms that are associated with geophysical methods and geophysics that has to be understood prior to going for any kinds of research. So we'll start up with the basics of geophysics. What is geophysics? So geophysics is used to study the physics of what by measuring the earth physical properties. So whenever we are talking about geophysics, like many of you must be interested to pursue your higher studies in various universities that in India or abroad, that is related to studies of geophysics. So what you are reading in that subject, you will be reading about the shape, you will be reading about the gravitational and magnetic fields related to the different earth observation and internal structure and composition of the earth. So that is the basics when you're talking about. So whenever we see earth, we feel like it's a somebody will say it's an ellipsoid, somebody will say it a spheroid, but we in remote sensing and GIS we consider earth as a geoid. So we'll be doing what is geoid, how this geophysics is applied. So when it comes to geophysical investigation or geophysics, you will be using the entire methods for various kinds of oil, gas, coal, mineral exploration. That's why even if after you are doing a master's program in geophysics, if you do from BHU or other institution of India, you've got a salary structure that ranges from 50 to 20 lakh rupees per annum, and that is because you are an expert in oil, gas, coal, mineral exploration, because exploration involves economical cost. So if you are good in various kinds of investigation, whether it is related to groundwater or whether related to any kinds of mineral prospecting, you will get a good amount of salary structure. So whenever you're talking about geophysics, you're talking about this groundwater, you will be talking about the groundwater properties characterization related to geoengineering like tunnels, dams, construction. So that's why geologist is very important, not only for any kinds of mineral exploration, any kinds of ground exploration, but also for geoengineering designing like tunnel designing, like dam designing, then archaeological study, then pollution mapping. So all these studies are very important when it comes to geophysics. So geophysics is mainly used to understand the various geophysical properties such as plate tectonics, magmas, volcanoes, rock formations. So these are the various kinds of plates. When you have already studied that there are various plates on which the earth is moving, whether you talk about Australian plates, Philippine plates, Indian plates, Arabian plates, African plates. So there are various plates that has to be studied before you're going for any kind of exploration or construction or identification or mining. So geophysical study or survey are the geological methods using ground based physical sensing techniques to produce detailed images of the earth or the maps of that area. So there are many methods that are used that can be invasive or that can be non-destructive, and it's important goal when you're surveying culturally sensitive areas. So you will be finding that whenever you go for exploration, the areas where you will be going, they will have a different culture, they will have a different language. So you have to have a acclimatize, you have to have habitual to all the cultural significance of that area, because if you are going for exploration, generally the area where you're going will be travel dominated area, means the interior parts of the world or in your country. So there you'll always face the problem that you'll be considered as outsider. You have gone as a, they'll feel, the local people will feel you as a threat to their resources. So you have to make them understand ki why you are there, what is the basic logic. And for that you have to have the entire scientific content involving the people of that area in order to have a better understanding of that area, and finally identifying the geological interpretation based on the basis of these anomalies. So many times when you will go into the field, if you are not connecting with the local people, they won't allow to survey that portion of the earth where you were interested in. So if you are very good enough in your subjective knowledge, if you are good enough in their cultural knowledge, you can make them understand in their local language or with the help of some local administration ki why you are, what is the benefit if you are doing such kind of survey, and finally what is the society, how it is going to be benefited from those kind of survey, has to be first created as a awareness programs among the local people so that you can go to your point of origination. So why geologists use this geophysical survey? Because when they cannot get direct access to the rock, when, because if you're not getting direct access to the rock, you have to identify the resources without sampling or disturbing the surfaces. So if you want to have something that is below 200 meters or 300 meters below the ground, so how you will understand ki what is there, how to get those samples? So for that, the different kinds of geophysical investigation or survey is important to detect the buried features in difficult to reach areas or without excavation, because you cannot have excavation in each and every portion of the earth that you can go and you can take the samples. So in case you are not able to take the samples, you want to identify their signatures on the surface. So you will be using the geophysical observation, whether it is related to rock, whether that is related to oil, whether that is related to water, whether that is related to any mineral. So when they are studying both the small and large areas, looking respective to the local or regional anomalies to test if the minerals or the metals are present beneath the surface of the earth. So why geologists again use geophysical survey? When they know that they are looking for is a knowledge driven approach where differentiating the granitic intrusion from massing sulfides using densites, and you have to identify this different kinds of observation. So if you have got some faults are there or some ore deposits are there that is beneath the ground, we are in the top of the surface of the ground. Now you need some instrumentation, you need some scientific methods to identify these resources on the basis of the surface anomalies that you are finding on the ground. So for that, you have got various kinds of methods through which you can do various kinds of survey. So that can be on different basis. One can be on small scale, that is localized in nature, and the other one can be regional scale, that can be of a regional scale. So when we are talking about small scale, we are talking about single drill hole, means you're localized to a particular point and there you will be taking the entire samples, whether you're putting a drilling or whether you're going for the seismic survey. And the other one is basin wide survey, where the large area has to be investigation, where you will be using the various kinds of properties of the rock for identification of those resources. So when you are talking about what is the magnetism of a rock, magnetization is directly according to the earth magnetic field and it's proportional to it. So when we are talking about magnetism, we are talking about the magnetic properties of the various ores, various rocks present in that area, whether that is mafic rock or ultramafic rocks, which has got a higher concentration of magnetite than felsic, metamorphic, and sedimentary rock. So generally, the geologists use aeromagnetic data to develop diagrams that map out the contacts that exist between this contrasting geological units. So what you will be doing, you have to first go and you have to have a survey in that area. You have to carry some equipments, you have to carry some gadgets. Maybe at each and every point you cannot go for a drilling. So for that you will be using the various kinds of airborne data, you will be going for the ground based study, and finally you will be going for the borehole study. So whenever you are going, all this cumulative approach has to be applied in any particular area, whether you're talking about oil exploration, whether you're talking about groundwater exploration. All these cumulating methods has to be identified, has to be applied in that area. So, using the physical properties such as seismic, gravitational, magnetic, electrical, and electromagnetic properties, that will be used to identify the anomalies. So, whether that is related to their chemical property, whether that is related to biological properties, all has to be identified. So, when you are going for the exploration by geologists, you have to map the subsurface features on the earth. So for that you have to identify the underlying geological structures, maybe many of the such structures that are indicative of some resources, whether you talk about any resource, those features has to be identified. So for that, this geophysical survey or geophysics has got its own importance and relevance, like identifying the geological structures, then geometry of intrusive rocks, whether that are dikes or platoons, then potential economic and mineral deposits, whether that is related to uh, exploration of gold, copper, or zinc. So all these methods has to be employed. So whenever you are talking about prospecting and early exploration stage, before you're going for any exploitation, first you have to explore. There is a difference between exploration and exploitation. So right now we are going for prospecting. Prospecting means ki first we have to identify ki is there any prospect of getting those resources. For that, first you have to do some kind of survey. So right now you will see that there is a lot of fight going on in national media. If you open any national channel, ki whether this time the census, the population that will be surveyed by government of India, there the data set should be coming up in terms of caste category, because of the last survey was done in 1931, and on the basis of that each and every caste has been classified into various religions, and on the basis of that you're getting various kinds of reservation key, whether you're classified into general category or you're classified into OBC, ST, and SC. So prior to that, what it is important, if you want to have a difference in those categories, the current many of the political parties are suggesting that they should update the data sets. So that can be done only using survey. Until unless you are not surveying it, you cannot come to a conclusion. In the same way, whenever you're going for any kind of exploration for any resources, first you have to have a survey of that area, a prior understanding of that area, so that you can come to a conclusion. Directly, if you send to me today to Rajasthan, or you send me today to Assam, and then you say ki which are the area, just let me know ki where I should go for groundwater exploration, or whether where I should go for ore exploration or any gold exploration. I cannot go directly and I can say that this is the area and you start exploring it. For that, first scientific methods has to be applied, and you have to have a different kinds of survey methods so as to have a basic understanding, so that when you are going for exploitation of that resources, means for extracting it, first your data should be 100% accurate. And for that you have got different kinds of survey, whether that you're saying is related to magnetic survey, radiometric survey, gravity, or electromagnetic survey. So there are the various kinds of survey that has to be done in before you are going for any kinds of exploration. So when you talk about aeromagnetic survey, so airborne survey has lower resolution than the ground based geophysical survey. So obviously each and every methods has got its advantage, each and every methods has got its disadvantage. So what airborne survey disadvantage is ki if you are going into the field, like if I go for the free satellites that are available for remote sensing data sets, the highest resolution that is free of cost is of 10 meters. 10 meters resolution is there. So if I want to go and have a planning for Gyanviyar University, for example, so there the data that is free of cost won't help me out because the resolution at which I'm trying to work or I'm trying to get which are the spot where in the Gyanviyar if there is some groundwater that has to be explored, or is there any diamond beneath the ground or gold that has to, I cannot say because of the resolution. That's why when you go for the ground based survey, the resolution is high because you're going at a localized survey. But when it comes to the airborne, when it is a drone based survey, or that way that is a aircraft based survey, there can be a problem of resolutions, because many times you will be requiring a high resolution data, and for that you have to provide and perform a drill hole. But not only you will be having a disadvantage, you will be having a advantage, that whenever you are going for a airborne geophysical survey are conducted from light helicopters or light aircraft in a regular grid form, that you will be studying in detail in coming slides when you will be reading the uh, topic remote sensing and GSK, what are the fundamentals that we are using in that subject. So, but as you have seen that in coming years or coming days, there are a lot of intrusion that is coming up in our borders, where the government of India has restricted the use of drones in the boundary areas of our country. That is because that technology is being used for the negative, because each and everything has got positive and negative. So the terrorists are using that technology in negative respect. But we as a geologist, as a remote sensing scientist, our prime responsibility is used to this equipment for the positive sides. So, what is the biggest advantage whenever you're doing a aerial survey? Because you cannot approach to each and every portion of the ground. It is inaccessible. You cannot go and get a geophysical survey for each and every portion of the ground. So, when you are using a airborne, it is possible to cover a large inaccessible area without requiring any line cutting or without going into the field, and that reduces the cost for the large area of geophysical survey. So that is the biggest advantage. Then that are being used for various kind of land use development programs in India, whether you talk about ISRO, whether you talk about forest department, water department, urban department, each and every department is using drone technology for the land use development and management. Apart from this, if you want to go for high precision accuracy related to your mining status, whether you have explored the entire mining, what is the current scenario, what are the further resources that has to be identified. So there the geohydrological map, geological map, environmental map, archaeological map, and even for the military researches we are using the aeromagnetic survey. So aeromagnetic geophysical survey consists of measuring the intensity of geomagnetic field in order to detect the local magnetic variation from the rock. So what is the basic principle, that each and every earth has got different, each and every features has got different reflectance in different electromagnetic band, will have different magnetic property. So what we'll do will be identifying these different magnetic properties in different spectral terrain to identify the different mineral composition, so as we can identify the exact resources or the ore which are we are going for exploration. So resulting aeromagnetic data will help us to support the geological formation of mapping to detect any concentration of magnetic material. So we'll be using those magnetic properties to identify the different earth material, because each and every material will have got different chemical property, has got different electrical property, has got different magnetic property. Like with the human beings, we are boys and girls, but if you go for the shape, like Rahul has got a different shape and size, the Vanshu has got different, Kritika is different, Kajal is different, Suraj is different. In the same way, in the earth also, each and every object is different. So we can identify those features, those properties, in order to understand what the specific feature is there at that particular point of investigation. So when you are going for the magnetometers are fixed onto the aircraft, a helicopter or UAV that flies on that area by performing a series of equidistant linear pathway to collect the magnetic measurement. So what we put a sensor, and it continuously measured your area of investigation, and thereafter those investigations, those data are processed in your computer, in your softwares, so as to get the maps, models where the geologist can predict the various properties, the anomalies, and finally you can go for investigation. For the normal or the latest method that we are using is geophysical, is drone based surveys. So nowadays you'll be feeling that the drones are used not only for the agriculture mapping or for crop acreages estimation or crop damage assessment. It is also used for forest damage, for groundwater exploration, because of its high resolution data when you compare it with the ground physical data. And it also has got a lower cost and without having any resort of line cutting, so you can have a exact identification of those area. So why it's useful? It's useful for various kinds of deposits, whether you're going for iron deposits, titanium, then cumberlatic pipes that are indicative of diamond deposits, then bauxite deposits, then real earth deposits. So all such deposits can be easily identified. Then you can identify and locate the various kinds of deposits of chrome, nickels, which are associated with ultramorphic rocks, then the volcanic massive sulfides deposit. So whenever you are going for aerial based survey, that is the best method. That's why each and every department, if you have got a degree in remote sensing and GIS, they are capable enough of getting employment. Because if you see our employment of your seniors who are pursuing remote sensing and GIS in this COVID era, also their 100% placement is there, and that is because of this technology. They are masters in this equipment. They can interpret the data better than a layman. That's why they get a high salary structure from the other students. So when you compare that with a ground-based geophysical survey that is conducted from the ground, that is used as for the seismology, that is a study of natural earthquake and the seismic wave. Then you have got magnetic survey, where you will be analyzing the different magnetic fields and magnetic anomalies. Then you will be performing the electrical survey, that is known as resistivity survey or VS sounding. The two methods that are very popular for groundwater is electrical survey, that we'll be doing in our coming slides, related to resistivity methods and sounding methods. Then you've got radiometric survey, that is indicative of radioactive detail, isotopes dating, gravity survey, where the gravitic properties, then electromagnetic studies, GPR are used, that is ground penetrating radars, borehole survey, lidars, geothermal methods. So you, these are the various methods. It is not necessary that you will be using the entire methods at a single area, but the more you are equipped with the various surveying methods, you're more qualified enough to handle the large data sets. Their interpretation, their accuracy is high, and you'll get a good job. So at last, when you're going for the passive methods, that is measures the spatial variation of statics and natural fields of force, lateral subsurface measure materials variation that gives rise to spatial variation, and finally you'll be using all these methods, whether that is magnetic, gravity, or radioactive in that area. And then you have got active methods, where you will be measuring the wave field characteristics, whether we are talking about time of electric elastic waves, then amplitude phases of electrical magnetic waves, then the energy that are stored and that are introduced into the surface area will be studying that. And there in the active methods we'll be going for the seismic survey, electrical survey, and electromagnetic survey. So how you will be doing all this data surveying, how you will be performing this data. So the ground-based geophysical survey are conducted from the grounds, begins from marking of the site into the survey gates. So whenever you are assigned with any kind of survey, you cannot directly go and start just running your drone without any. You go and start drilling it. There is no way you'll get the accuracy in the data. Your the entire results will be a flaw. Prior to going into the field, you must have some scientific understanding, a method of getting that data set. So what we do is we just divide the entire study area into various grids. A grid is created on the land. So what you do, you'll be creating the various grid, also referred as line cutting, marked by narrow cut lines in the forest or lines of pickets on open land. Now the reference points placed along the corners of each grid marks of the collected data to minimize the positioning error. So what it's important, you will be defining and you will be identifying each and every grid so that the amount of error when you're projecting that into the map, because all the data what you're collecting is on the field, now you have to convert that into a map. So until unless you don't have a reference point, how you can, if I say okay, I am right now into which place, Dipanshu is in X location, uh, Deepika is in Y location, how it is possible ki where you are located? So you need a reference point. So prior to going into the field, whenever you're dividing the area into various grid, you have to use the various reference points like benchmarks. You will be getting a Survey of India topographical sheets that are the fixed geo positioning location that doesn't change in the landscape. So we have to identify those geophysical or the reference point that are fixed and that has not changed over the decade, so that when we'll be transferring the entire results into the map, the accuracy related to the positioning, related to the analysis is near about 100% accurate when you're talking about geophysical results and measurements at regular interval. So whenever you're talking about groundwater geophysical survey converted from the ground, you'll start marking the survey grids. Additionally, you'll be using those aerial photography to map the different kinds of geological features, the various kinds of rocks, minerals, trenches, digging a long ditch on the ground to examine the geology beneath the surface. You'll be using the electrical survey. You'll be using the various other techniques to identify those resources. So data processing and imaging allows the conversion of raw numeric data into interpretable maps, because when you're using a instrument, the data will be recording into machine form. Now you have to convert that machine information into form of some graphics, in the form of some statistics, in the form of some maps, so that a layman, a person who is not related to geology, can understand the scientific investigation that you have carried out, so that you have to make the data ready, interpretable, so that each and every person, a layman, a person, my father, can also understand what I am trying to say. And that can be if you are normalizing the data sets. So you have to recognize the cultural and natural pattern, you have to visualize the physical features, you have to interpret the causes of anomalies in that area. Then you've got seismic survey that involves placing geophones sensors connected to the wires in strategic patterns to provide information about the properties of land that is thousands of kilometers of the earth. Because whenever you are talking about geological features, we are not talking into a specific location. Those features are generally covering in thousands of kilometers. So the survey team will induce vibrations using truck mounted vibration weights, or a small explosives will be done. Then the vibration from the weights or the explosives are recorded with geophones to provide the information about the properties of rock. So they are the different surveying method that you have to have a expertise, so that you can measure the vibration that is passed through the layer of water. Then the reflected vibration is recorded into the instrumentation, and then we'll go to identify the anomaly. So the reflected seismologically called as seismic in the minerals industry is the practices of inducing a vibration on the earth surfaces and analyzing the reflection. So you can see that this is a detector that is going on, and it is producing the different kinds of records. The blasting is going parallelly, the shock waves are thrown into the ground, and the reflected waves are being recorded by the instrument, and finally you will be converting those information in the form of graphs, in the form of a graphic, so that you can understand and you can identify the anomaly of that area. So the vibration is induced using a vibration machine or a series of dynamic blasts. This created a seismic wave that travels to the Earth's mantle, the ball of molten rock below, and finally the mantle reflects the wave back up to the surface where they are measured. So what I've already stated, how the data will be sent, means this is the act of incident energy, and this you can say as reflected energy. So reflected energy will be recorded. Now we know what are the different kinds of anomalies that you'll be identified. So you'll be seeing all this seismology uses the speed of seismic wave to resolve the rock density or the state. So various kinds of waves that can be used to interpret the state and the intensity of the earth atmosphere. So you'll be using all this terrains to understand the different kinds of 3D composition of the earth, the 3D figures of the earth, and these are the various instruments that are used in the field. You can see the different geologists are performing the different kinds of activity related to seismic survey. These are the trucks that are used for receiving those signals. So this is the truck, and you can see how the data are being sent on the ground and the reflected energy is being recorded. And this is the final map that has been prepared on the basis of those data sets. And finally, you can provide the interference, and you can see there are various kinds of differences and reflectance pattern, and you can identify the different faults and different lineaments, the different factors on the basis of this data sets. That's why survey is very important to get a basic understanding of the underlying Earth's data, and that's why the use of technology has provided a new dimension to the entire geological investigation that we have done. So the more you are coming up with new instrument and new seismic data, so you can see that how the data are being recorded, how the data are being analyzed, how the data are manipulated. Then while recording the data, you will be finding various kinds of errors. Those errors has to be rectified finally before coming to a conclusion. And finally you will be using all these hydrocarbons like oil and gas and coals occur in stratified sedimentary rock, since they are very originally biomass like forest or grasslands that can be covered with layers of rocks. So these layers are easy to spot with seismic wave, allowing the geologist to easily pinpoint any variation in the layers that might contain hydrocarbons. So using this method, you can easily identify the different resources that are hiding beneath the ground, and you can see what are the various earth features that are stored and that are located beneath the ground. Then you have got hard rock environment where the minerals tends to occur before the sedimentary rock in igneous or metamorphic rock. Hard rock environments are extremely complex and much more difficult to analyze seismically. So each and every data sets, each and every method has got its own positive and negative. Unfortunately, due to popularity of the seismic waves in the oil and gas industry, many geologists use it exclusively and do not apply any more appropriate methods when you're exploiting for minerals. So the various researchers are only using this seismic waves if you are going for any kinds of oil and gas industry exploration. And finally, related to the environment, the vibration, especially when caused by dynamite, have many negative environmental aspects. So you will be seeing that recently there was a landslide in Uttarakhand that related to collapse of a hydropower. And if you go for the reasons, many of the local state that in prior few days or few months back there was lot of a small explosive or smoked the explosion was done in that area, in the upland area, that created the vibration and that created the instability in that area, and finally a portion of the land fall down at the top of the watershed, and there in the lower watershed you had got that a collapse of that hydropower where a lot of people lost their life. So that is the negative respect. Also, you're seeing a lot of landslides being recurrent in many parts of the country, because you are going on constructing, you're making 4 lanes or 6 lane routes in the Himalayan terrain, whether you're talking about Himachal, whether you're talking about Uttarakhand, Kashmir, that has created, that has unstabilized the entire Himalayan ecosystem or the mountains in that area, and that has led to a lot number of cases of landslides are recurrent because of this negative aspects of vibration. And this is the most popular methods when it comes to the remote sensing methods, especially for the glacier studies, or when you talk about earthquake related studies, that is GPR, that is ground penetrating radar. That is very important nowadays. In ground penetrating radar, the radar signals is an electromagnetic pulse that is directed into the ground. The subsurface objects calls reflection in the data. The timetable indicates the depth of the object. So you have created this. So speed equal to distance by time. So when you know the speed, you know the time, you can easily identify the distance. So in the same methodology, each and every sonar like navigation we are using in your various when you are going for navigation, we are using this methods to identify the subsurface objects. So GPR is best utilized in the sandy soils without a lot of clay, silts, or material that can cause metallic interference. Rock terrains or heterogeneous sediments can further create a problem. So you know this is a GPR. You can see the various radiations, electromagnetic properties are being sent on the ground, and finally you will be seeing such kind of images or graphics created using that method. And magnetic survey specify variations in the earth magnetic field due to the presence of the magnetic material, and small variations in the magnetic content of the specific metals allow the technicians to interpret the rock types and assist in identifying the various resources. So magnetometers provide better resolution of small near surface features. They respond strongly to the earth in respect of iron, steel, brick, burnt soils, and many types of rocks. It is very even possible to detect very small substance anomalies that are caused by disturbed soils or decayed organic materials can be easily. And finally you will be getting such kind of maps, and the images will be created on the basis of that, and you can go for magnetic exploration is much more complemented and precise than gravity exploration. Geologists use variation in the earth magnetic material to detect the certain magnetic ores and precipitate minerals. So these are the various methods on the basis of which you will be finding the various kinds of minerals which are associated in the complex rock types, and you will go going for iron prospecting or iron for formation associated with mineralization, or chromite or magnetic prospecting. So for various kinds of geomorphological methods or mapping, you'll be using these methods for structural mapping like fault, fractures, shear and folds that are subsurface, then structurally hosted deposits of uranium, stratiform, and finally depth to bedrock to determine the thickness of sedimentary section and overburden. So you can create such kind of geological map using the geophysical magnetic method, where you will be creating the 2D and the 3D of that area in order to understand the anomaly of that area. So finally the geological map will be validated using the geophysics based on the magnetic study, and you will be creating a 3D map of the geological area of that terrain. So you can see the exact amount of references and the faces what you can found below the ground can be easily identified using such instrumentation, and you can identify each and every anomaly. Like if you have got, this is the area like red are indicative of for example gold. So I can if this square is my area of interest, I can identify the exact resources of gold where we can go for exploration and exploitation. So getting it? So these are the various methods that we are using it for different kinds of investigation. So for today, I think it's more than enough, or you'll get confused. So we'll stop for today's